Welcome to the online launch session, Data Protection in DBaaS Environments. I'm very happy that we were able to attract such a large number of participants for this session. We have prepared some exciting topics for you. After the intro and overview by CEO and co-founder Antoine Coissier, we get into the topic Protection in Database as a Service Environments with Dave Beach from our valued partner Aiven. In the second stage, we will see a demo from Philipp Müller about automation of databases with Terraform. At the end of the webinar, we will answer all raised questions in the Q&A session with our experts. I would now like to hand over to CEO and co-founder Antoine Coissier, who oversees the business and the operational aspects of the Exoscale platform with 20 years of experience in the service provider business. I hope you enjoy the online session. The stage is yours, Antoine.
Thank you, Ben. And good morning, everyone. What a pleasure to find you back here after summer and talk a second time about database environments, data infrastructure services. I would first want to start with a general update about our products, what's new on the Exoscale platform. SKS, or Scalable Kubernetes Service, which we launched earlier this year, is still going under a very strong development roadmap. We're following on the release cycle of the upstream Kubernetes project. So now you can find, since a few weeks, version 122.1 already released. Remember, the lifecycle of the service is that we always maintain the two major versions of Kubernetes, with always the latest release from that version, and we try to make those available in the 2 weeks after their release from the upstream project. What has happened also this summer, if you missed our announcement, is that now all releases of SKS undergo the full CNCF conformance. So that's a thorough check, which is established from the Cloud Native Computing Foundation, and which enabled us to obtain for SKS the certified Kubernetes badge that you see on the right. So our commitment is that for each and subsequent release, we will do the certification process of the versions, enabling you to get the vanilla experience from Kubernetes, and making sure that from one version to another, everything works as expected. I picked out 2 features we released since a few months, but there are many others. So check out the changelog. There was a lot of requests regarding the private network support, and that's now done. And also now you can, regarding the lifecycle management, if you're confident, you can switch your cluster in auto upgrade mode, meaning that it will auto upgrade to the latest version we release, being supported. SKS is one thing, but other products, the compute, the general platform, are seeing improvements as well. New and updated templates. We released an Exoscale flexible storage instance to make storage management of your instance easier, so that you can play with volumes, locally attached volumes a bit more easily. We've done a first release of a portal enhancements, and there will be a few more in the months to come. So we are making clearer the separation between your user environment and the organization management. So the various workspaces in which you can have workloads attached with Exoscale. Last, if you missed that announcement last year, we released API v2, so we are migrating slowly all our interfaces to Open API standard. So the OpenAPI v2 coverage has been drastically increased. We're still targeting the fact that all methods will be switched to the new system by end of this year, early next year. So expect in 22 sunset of the version 1 API, like we had previously announced. Moving on to the database as a service. If you can have the next slide, please. Thank you very much. As a recap, so we launched in preview on July 6th with a webinar giving a first intro and demonstration. It was 3 services, so Postgres, Kafka, and Redis. We initially had announced Elasticsearch, but this is now deactivated. You might have heard of the Elastic saga this summer as well. So we're seeking a replacement along with our partner Aiven with OpenSearch. So that will come in the weeks to come. We'll of course keep you up to date on that. What's already released regarding Elasticsearch in regards to the pricing and etc. will be one-to-one equivalent with OpenSearch once it's launched. And the experience we've provided so far was really just the basic commands with the CLI, or everything which was more advanced management was not released. So today, would like to announce the general availability for the Exoscale Database as a Service suite of products. And for this, we are targeting next week, so September 14th, with the same 3 services. So what you will get is enforcement of the full SLA on the various plans, of course. Support will be then part of this SLA and be taking all your questions and requests for informations, and an extended documentation, just as we currently have only the quick start. So expect to have more details about how to do advanced configurations and how to tweak tunables of each data infrastructure instance. The user experience will be through the API and the command line interface. And then if we speak about general availability, that means all zones covered, and that means also that the billing will start. So the pricing you can check already on exoscale.com/ in the database as a service section. As a bonus, there will be the Terraform provider, which we'll showcase in the second talk today. That provider will be with beta support, so no guarantees on that one. What will be next? 2 things in addition with the OpenSearch release we already talked about. In the weeks to come, MySQL, okay, and also the web portal, so the ability to manage everything we're doing today in the demos with the CLI or API or Terraform, but with the web interface. A quick snapshot on pricing. I mean, just to compare, see where we are. Here, I mean, as of today, comparing Amazon, Google, and Exoscale in Frankfurt with services of the, I mean, similar size. This being aligned on, I mean, current generation CPUs and a memory size of 16 gigabyte with 350 gigabyte of storage. If we check the pricing, then I mean, you can see that we are still competitively positioned in that regard. Of course, I mean, with Amazon, you can play with reserved instances and things like this, but then you lose quite a bit of flexibility. There are also, I mean, further commitments that you can take with Exoscale. So, I mean, get in touch with your sales representative at Exoscale, with our cloud architects team, and we'll be delighted to do quotes simulations for you regarding the various plans, the various options regarding Exoscale Database as a Service powered by Aiven. Now, I would like to move on with the presentation from Dave, where we will see more details about the underlying product. Up to you, Dave.
Okay, thank you very much, Antoine. Hello, everyone. My name is Dave Beach. I'm a solutions architect at Aiven, based in the UK. So Aiven's a platform that powers the Exoscale database as a service product offering. So I'm here today just to give you a little look under the covers to explain the security, the features that we've got in place to help you protect your data. Now, if you joined the last webinar, or maybe you've read blogs or press releases, that kind of thing, you may already know a little bit about Aiven and who we are, what we do. But here's just a little quick introduction for those of you that might not be familiar with us. Aiven is a startup, maybe more of a classed as a scale-up these days, I suppose the definition might work. And we specialize in running open source software in the cloud, and that's it. It's that simple, really. We were founded in Helsinki, in Finland, about 5 years ago now, by 4 software engineers. And what they wanted at the time was to use open source data technologies like Postgres and Apache Kafka, but without any of the headaches of having to install them, maintain them, upgrade, fix bugs, replace failed servers, that kind of thing. And there wasn't really anything for them. So they built a platform for themselves and quickly realized that many, many others around the world have got the same problems. So that's what they did. They founded a company to sell this to others, and that's what we do now. We provide a rock solid service so that developers around the world can focus on what they do best, which is writing code, writing great code, and then we can worry about the boring stuff like keeping databases running. We're growing fast. We've got around 200 employees globally now, so we can provide these services all around the world and support them around the clock 24/7. Most importantly, and really why I'm here today, is that we were excited to announce this great partnership with Exoscale a few months ago to help provide these same benefits to organizations just like your own, where you care about security and privacy and you want to keep your data in the European cloud. So how do we do this? How exactly are we going to protect your data? Security is obviously a big part of this. I'll explain about the various security features that are built into the Aiven and Exoscale platform. We will also look at high availability, because having the data securely stored is one thing, that's really a good thing, but that's not very useful if none of your users and applications can actually access that data at all. And to expand on that a little bit, we will look at backup and disaster recovery, just to go that one step further and reduce the risk of data loss or downtime when things go wrong. So here we've got a very simple view of an Apache Kafka cluster over here on the right. Very oversimplified. There should be arrows all over this diagram, but please forgive me that, just to keep it a little bit more simple. So on the right, we've got Kafka running in an Exoscale cloud, and on the left, we've got a set of client applications which are going to be connected into the cluster. They're going to be consuming data, producing data, just using Kafka as they like. The first thing we're going to want to do is ensure that the data is very nicely protected as it travels over that wire between your applications and the data services which are running in Exoscale for you. And for that, we force the use of TLS, Transport Layer Security, or SSL to give it its other name. Plain text connections are just not possible, so there's no chance here of an application or a developer misconfiguring something, accidentally connecting over a plain text unprotected link, and exposing sensitive data on the wire that you would not otherwise want to. Next, what we'll do is ensure that all services are properly firewalled, so that only connections from trusted sources can get in the first place. You can lock this down as tightly as you like to a single IP address, or open it up to the entire internet if you'd like to, and anything in between. So this supports multiple IP ranges, CIDR ranges, and you can be as flexible as you like with the configuration of that. Authentication, authorization as well, both very important aspects of this. So we want you to prove that you are who you say you are, and once we're happy with that, then we need to check, what exactly are you allowed to do on these services. And the options here actually depend on the kind of database or service you have chosen. So for Postgres, you'll need a username and a password. By default, when you create a Postgres instance, you will get access to some administrator level credentials. And from there, you can go ahead and create other users and roles, grant and revoke privileges, just do all the things that you'll be familiar with your standard Postgres SQL commands there. Similarly for Redis, access is controlled using usernames and passwords, and there we can use ACLs to further limit access to certain keys or commands, categories of commands, however you need there to lock that down. And with Apache Kafka, we've got other options. So as well as username and password, we also have the ability to present TLS client certificates to prove our identities in that way instead. Access control lists are also supported here so that you can limit access to certain Kafka topics, maybe allowing some users to only read data and not write, or write data and not read, or any other combination. And then going a bit deeper behind the scenes of each database service, data is always fully encrypted, both at rest and in transit. We use industry standard open source tooling for this. We haven't reinvented any wheels here. All the disk volumes are encrypted using LUKS, using AES encryption, I think with 512-bit keys. And all communications in between nodes of a clustered service like Kafka or a redundant Postgres service happen either over TLS or over VPN, over IPsec tunnels. The keys for the volume for the disk encryption are individually generated for each volume in each VM instance. And these only exist in memory for the lifetime of that server. So there's no storage, there's no central point where we're collecting all these keys that could be compromised, and the keys are not going to be stolen in bulk ever. And because those keys only exist for the lifetime of the VM, that means we get automatic key rolling periodically when these servers are replaced, either when they get self-healed if something fails and they get replaced, or just as standard during upgrades and maintenance kind of operations there. So one other important thing I'll mention here, we've got the complete security picture on the screen now, is that the virtual machine instances that we create for you to form your database service, they're totally dedicated to you. They're only for your organization, no one else's. They'll only be accessed by you and possibly by the Aiven operations team under very rare, certain circumstances where we need to get on there and fix an issue that's raised by you during a support call, for example. All that access is obviously tracked and audit logged, so we can see what's happened there. But I mean, access like that is quite rare. The operations on the Aiven platform are pretty much fully automated anyway. It's rare that one of our ops staff will need to directly SSH onto one of these machines and do anything directly. But in any case, we will never access your data, any customer data, unless you explicitly ask us to, and it is absolutely necessary to to troubleshoot or fix some issue that's going on. So things are secure, but how do we make sure that these things keep running so your data is actually available whenever you need it? High availability for databases on the Exoscale platform is dictated first by the service plan you choose. Now, these are divided into tiers. We've got startup, business, and premium. Some services like Postgres have an even smaller, very low cost plan called Hobbyist, which is like startup, but with a very, very small instance type, just for playing around with. For Postgres and Redis, the plans come with either 1, 2, or 3 servers. So in a startup plan, you only get a single VM running your database, so there's no high availability as such. If that server fails, it will automatically be replaced, and your last backup will be restored. But there is a small chance of some data loss there. Whatever was written between that last backup and the time that the cluster failed. So to avoid that and to make sure your service keeps running while that self-healing process runs, we need to go up to the multi-server business and premium plans. And these come with either 1 or 2 standby nodes, which are continuously being replicated to using standard PostgreSQL or Redis replication. That way, if any server in the set fails, the service as a whole will remain live. And I'll talk a bit about the process by which that happens in a moment. Backup frequency and retention is also variable and improves as you go up the tiers of the service plans. So it's fair to say generally that as you do move up through the tiers from startup to business, then to premium, the ability of that service to survive or recover well from all kinds of things gets better and better. I'll talk a bit about, well, more about backups in the next section too. Also, a quick note, within the tiers themselves, there is a sliding scale. Like in business, you'll have business 8, 16, 32, etc. And as you move up in that range, the amount of storage and compute resource goes up. So performance goes up as well as the price, of course. But really, within the tier family, the high availability features will stay the same. With Kafka, your default high availability story is a bit better because all the plans are highly available as standard, even the low-cost startup tier services that are only really meant for development and testing use. So these, as well as the business tier plans, come with 3 nodes, and all that varies then between the startup and business tiers, and within that range then is the amount of storage and compute resource, as I mentioned before. So startup has less and business has more. To get even better performance and resilience, we then need to move up to the premium plans and scale horizontally. Here in the premium range, we've got 6, 9, 15, or 30 node plans available to choose from. And for Kafka, a higher node count can be a good thing for a few reasons. One, to handle a larger number of partitions, and to reduce the chance of performance hotspots, since the leader partitions of your topics will be more evenly spread across a larger set of brokers. I'll just quickly run through the process of what happens if a node fails and how the service keeps running. So here I've got a premium tier Postgres service, and we know that because it's got 1 primary node and 2 standbys. And in this case, unfortunately, a standby node has failed. Now, you don't need to do anything to recover from this. The management software underpinning the platform will detect this for you and automatically will go and create a replacement for that. It will restore, that node will be brought up from the latest backup, and then all the most recent changes will get streamed from the master to bring it fully into step with the cluster. Once that process is finished, we can then kill off the old unused node, and the new standby node is back, is joined as a full member of the service again. If a primary node fails instead of the standby, then the same kind of process of replacement node, will happen. There's just an extra step of failover. So one of the standby nodes will be promoted to become the master, and then the new node will become the replacement standby in that case. But in any case, your clients, the applications connecting to this thing, don't really need to care so much about that. The DNS entry, the service URI you use in your connection string, will always point to the place it needs to go. So there'll be a DNS change at some point in this process. There might be a second or 2 interruption where clients need to reconnect to discover the new primary, but in general, that's not going to cause much disruption to anything. For Redis, the very similar procedure here, really, and on the screen is the scenarios of a master node and a standby node failure, but the same kind of process applies. We'll make a failover decision to bring, a new master on board if needed. A brand new node gets created as standby, and the old dead node gets terminated. Okay, so we're secure. We can make sure our services are highly available. brilliant things, of course, but sometimes that's not quite enough. We do need a plan for when things go badly wrong, even though that's very rare and we hope never happens at all. But we still need a plan, and let's talk about what we can do. Backups are a key part of this. So your Postgres and your Redis services will be automatically backed up to Exoscale simple object storage service periodically. This is really important, as mentioned before, when self-healing kicks in and a new node is brought back online. These backups are like critical for then bringing that node back into the cluster quickly. And as mentioned before, the frequency of those backups and the length of time you keep them is determined by the service plan that you chose when you created your service. So for example, in the case of Postgres, on a startup plan, a full backup, backups will be happening at once a day, and the previous 2 days worth of backups are kept for a startup tier service. If you move up to a business plan, you get 14 days of retention, and premium goes further to a full 30 days. In all cases, though, a full snapshot is being taken every 24 hours, but we're still constantly backing up the transaction log every few minutes. So when there's a file rolling over in the background, those changes get streamed up to object storage immediately. And this allows us to provide not just restoring from that snapshot once a day, but a point-in-time recovery at any point throughout that 24 hours as well. So these backups will end up in simple object storage in the same Exoscale zone as your actual database service. A reasonable question then will be, what happens if the entire zone fails? I mean, this is going to be very, very rare, of course, but it's still an important thing to consider for disaster recovery planning. And there'll be that box to tick in your DR plan. So to cover off that point, what we'll need is some kind of multi-zone solution, and database forks are one way you can achieve this. Now, forking a database is like copy-paste. We have a database running in one zone. Here, the primary zone, I've chosen the Frankfurt region in Germany. But say we want to create a fork of that in a different zone, Munich here. So we can create a fork, we'll create a new service in the secondary zone, but rather than just bringing it up from scratch, we'll say, actually, while you're creating that, please create a fork of my existing service here. And then all the data, all the configuration of your first service is replicated now to the new one. You don't necessarily need to use the same database engine version or the service plan. The size of the machines can be different. I mean, that's a good thing to do for a few reasons. If you make your fork smaller or bigger, it could be good in terms of performance benchmarking or comparison with your applications. Or if you create a fork based on a different Postgres version, for instance, you can test upgrades, you can test compatibility and make sure your applications still work with that new version. They're all very good reasons, not as relevant to the topic today as for data protection, but still quite good ideas, I think, to consider. But the main reason for doing all this, as we're discussing today, is for data protection and having a full copy of your data accessible in another location in case the absolute worst happens. And what that means as well is that the backups of your fork will live in the same zone as the fork. So we've got backups of your primary and backups of your fork going into that secondary zone, and we've got multi-zone backups as well. For Kafka, we don't do backups in quite the same way. Kafka's not as easy to back up because the data volumes are generally much larger, and also for a lot of use cases, it's just not important to back up Kafka at all. I mean, these things are often like a transient store, like a buffer. Data is coming in and streaming to somewhere else, so keeping a huge backup of everything in Kafka is not always the most useful thing to do. But we still need options for providing geo-resilience and doing multi-zone architectures, and MirrorMaker 2 is the solution by which we will provide that. So Apache Kafka MirrorMaker 2 is open source. It's part of the upstream Apache Kafka family, and Aiven and Exoscale provides a managed service of this that you can purchase and run alongside your Apache Kafka service. and hook it up to flexibly replicate things between zones, between clusters. It doesn't have to be between zones. You can have two Kafkas in the same zone if you'd like to. But here what we can do is have a Kafka in one zone, a Kafka over here in a different zone, and a mirror maker service running alongside the, usually you'd want it alongside the one you are writing to for best performance, but it doesn't really matter. And from there, you can configure replication flows to choose all topics or just a subset of your data to stream from one zone to the next or back as you like. That's quite useful as a cold backup, but you get more than that here, don't you? Because this is the full Kafka service. You've got all the power of Kafka in this different zone. So this really unlocks all kinds of possibilities now for different architectures. With mirror maker replication, you can have a completely passive service there, just waiting to file over to. So all your applications could file over to that second zone if the primary one goes away. Or you could even do a full active-active mode where actually both Kafkas are being used simultaneously by your applications, maybe chosen by which apps are running close to the zone in question, and then mirror making take care of streaming the changes between the two. So really, this opens up quite a lot of options for you to build nice architectures that span zones and then become resilient to the loss of any individual location. So run through quite a lot there. Just to cover what we discussed, 3 main areas of security, high availability, and backup disaster recovery. We can help in all 3 areas here. So for security, we're going to encrypt everything everywhere. That's the main point. We don't want to see any data being left unencrypted. I'm not sure I mentioned backups. I hope it goes without saying, but I'm going to say it anyway. The backups on object storage are encrypted, just like the services that you're running as live. So everything will be encrypted and protected at all times. We've got boundary controls so that no one can get in who you don't want to. Authentication, authorization to make sure that only the right people are doing the right things. And then privacy and compliance as standard. These things are just for you. No one's snooping on your data that you don't want to have. For high availability, multi-node plans, as I explained, and that self-healing capability to make sure that when things go wrong and computers do fail, we need to be able to bring them back automatically, seamlessly, and keep your service running without any problem, any real need for you to do anything to fix that. And then just to protect ourselves further for the worst case scenarios, we've got comprehensive backups to object storage, and those options there I set out to bring in a multi-zone architecture, so you truly are resilient then to any kind of failure. Okay, thank you very much for your attention. I'm now going to hand you over to Philip Miller, who will be showing you how to provision these things and manage your database as a service using Terraform. So, Philip, over to you. Thanks.
Thank you very much, Dave.
So good morning, everyone. I hope you can actually hear me and see my screen.
Yes.
That's perfect. So I'm going to showcase a demo on Exoscale using infrastructure as a code. Before we start looking into the live environment, let's have a look why infrastructure as a code is actually benefit in many environments running on a flexible infrastructure like Exoscale. So first, we all know those experiences in current environments, like you getting called because the deployment went wrong based on documentation that was outdated or old, or you wasn't aware of, and you need to fix it. Then you have the developer who finds its application not performing well or not running at all because the production environment was not built and configured as he wanted it to be. As well as there's always those deployment jobs you have to do again and again and again. So What to do about those topics? Actually, infrastructure as a code pretty much addresses similar issues as the standard code development you currently use to develop your code base. You have the infrastructure documentation because all of your infrastructure actually moves into your code revision tools like GitHub. So you have revisions, you have commits, you have the commit list, and you can actually see when, who changed what part of the infrastructure. Build, deploy, and change easier. Infrastructure as a code tools like Terraform, I will showcase, makes it extremely easy and fast to deploy infrastructure to new locations or change infrastructure to new demands. Then you also get a reliable infrastructure state because the infrastructure is clearly defined in your code base with your code. You can be sure that the infrastructure, even if it's deployed in different locations by different team members, is looking the same. And you can expect exactly the same behavior from each deployment. So by defining your infrastructure within your code that will be executed on the infrastructure, you enable yourself to deploy rapidly, consistently, reliable, and all of this in the same tool sets you used to use for your development. So there's not much new to learn. So what we say is don't build your infrastructure, commit it. So let's hop to the infrastructure demo setup. So just assume we are a software developer also providing infrastructure for the developed environments, and a customer of us engages us. I need a web-based application with a high level of availability and reliability. It should be able to scale with my business demands. I want to extend to the DACH region. I need to have this deployed in new locations on short notice. So our answer is say no more, we got this. Because we will use Terraform, GitHub, and the Exoscale to deploy this environment based on Exoscale Kubernetes service and database as a service. And Terraform is an infrastructure as a code tool that comes with a managed provider from Exoscale. So we provide all the required function and resources Terraform needs to actually get an environment running. So let's hop to the live demo. And the first thing I'm going to share with you is actually I have a small GitHub repository created with 3 files in there. Runbook is my cheat sheet for the demo, so I know what I'm doing. The README is just the README, and this is actually a Terraform file. And what I'm going to show you is the content of this file. So if I look into the file, in the beginning, I'm defining some variables and some locals. I'm defining a project name that is a database as a service webinar or the short term. I'm defining an API key and an API secret. That is actually the API key we need to give Terraform to allow Terraform accessing the Exoscale environment. I give a local zone. That's actually the Exoscale zone in Frankfurt. So I want to have this deployment to be in Frankfurt. Then I actually tell Terraform that the required provider for this deployment is Exoscale. And I want to have the latest version that is 0.28.0. For this provider, I need to define the key and the secret. That are those variables I just hand over here to the provider. Then I actually start building resources. And the first resource I build is a security group because I need my firewall to allow certain communication for my project. So I create a resource Exoscale security group with the internal identifier SKS and with the name of the variable of the project -SKS. So I actually take this name -SKS to keep the deployment and the naming variable. Then we need to have some rules in the security group. So I create rules for the security group SKS in the security group SKS.name. And what I do is I create ingress routes for the Calico CNI that is used by Kubernetes to actually control network traffic. I use a security group for the nodes logs exec, that's a kubelet API, so that the nodes and the master can communicate properly. And the scope of those both is the own security group. So it's not the entire world can connect to them, but only systems within the same security group. The last rule I define is the node port services that I expose to the entire internet, because those are the services we later have the developed application running towards the world. Once I've done this, the next resource I define is the Kubernetes cluster itself. So it's the Kubernetes master. I want to have it in our local.zone. That's the zone I actually defined in the beginning of the script. And again, I give it the project name -prod. I also want to have the latest version available, so I can give it a version flag as well. After deployment, I actually want Terraform to output my API endpoint of this created cluster. So I configure an output for the SKS endpoint. The next thing I need to define is a node pool, because a cluster without any nodes can't run any compute workload. So again, I take the resource definition with the local zone. I give it the Exoscale SKL cluster.prod.id. So this cluster is named prod. So I give it the ID to attach this node pool to the cluster. Again, I give it the project name -node pool as a name. And as we're starting with a development environment, I want to have a standard type instance and the size is small. That's the smallest we can do. And I want to have 2 of them. As a security group, I want to have all of this node pool to use our security group we created in the script. Then, as we need to have a database in the backend, I also define an Exoscale database. Here's the pgprod. Again, in the same zone, I want to have it named, again named with a project name -prod. Type is Postgres, and the plan startup 4, it's the smallest plan, because again, we're starting with the development. So we want to save on resources and using the least or the cheapest solution available. I can give my Postgres several further information, like I want to have the maintenance on Sunday at 11 p.m. As this is still in development, I don't need any termination protection. And I want to give it the PG version 13. At 1 a.m. is my backup hour. I only want to allow 1 node for now. So I have an IP filter with a single node. And I already defined my max failover replication time lag to be 60 seconds. Then I want to output the database. I can access the database. You see the statement sensitive true. That is mandatory because that statement actually contains username and password. And so Terraform won't report it on the shell. So now let's switch over to a Linux system. This is my jump host, and let's have a look how I can actually use this infrastructure as a code on a system. First, what we do is actually we download the Terraform executable. We unzip it. You can find different executables on the Terraform homepage. We make it executable, and to easy use, we move it to /bin. Let's test if that worked. Fantastic. So that's all you need to set up Terraform. No different or other configuration required. That is done. What we're doing now is actually we're cloning the repository I just showed you to our local Linux system. There we go. Let's have a look. It's containing all the 3 files. That's fine. So before we go into the deployment, I just showcase the current environment using the Exoscale. Let's have a look what's in there. So we only have the default firewall group that comes in each new account. We don't have a Kubernetes master running. We do not have any node pools running. And we don't have any database services. As you note, the database, as it's still in beta, is in our lab section of the CLI. Once this is in general availability, you will just have Exo database in your CLI to access those features. So we have a completely empty, fresh new account. So let's start with Terraform. The first thing to do is with Terraform initialize. That will actually let Terraform scan the current directory for a .tf file, a Terraform file, read it, and download and configure all required provisionals. So there we go. Terraform found the Exoscale provider matching the version. It's installed the provider, and it also showed that this provider is signed by HashiCorp. HashiCorp is the maintainer of Terraform with a given key. So this is an official provider, and Terraform has been successfully initialized. Perfect. Let's validate the current checkout. Validate actually scans the .tf files and checks them for syntax errors. So this is a success. The configuration is valid. That's perfect. So now we're actually going to apply the Terraform script. And apply means we're going to run the script and deploy the environment. It's now asking for the API key and the API secret. And there's no need to type down that secret for two reasons. First is everything is recorded, so you will be able to see the secret in the recording. But the second is, as I'm using a cloud infrastructure, neither the key nor the entire account will be there once you get your hands on the recording. So what Terraform now is showing here is actually what it's going to do. So it will create a database with our configuration. It will create a security group with our rules in it. It will create the cluster. It will create a node pool, and it will give some outputs. So what I'm actually doing now is I'm confirming with yes, I want to deploy. And now Terraform is doing all my work in deploying the entire environment. So this will take some time, approximately 2 minutes. And for those 2 minutes to run, we can switch to a different shell on the same system and just have a look if there's already stuff coming up. So I list my Kubernetes clusters. And as you can see, now I have a Kubernetes cluster running with the name DB as a service -webinar -prod. That's the project variable with the -prod in the zone Frankfurt 1. Perfect. And I also have a Postgres deployment. Again, the name is the same because I use the same variable -prod. The plan is startup 4, same zone. Yep. And there's actually my firewall rule set. Let's have a look on the rules. And I can see I have 4 ingress rules, 2 from the same security group for the kubelet API and the Calico CNI. And then I have 2 rules, one for the IPv4 internet and one for the IPv6 internet for the node ports. So everything we actually defined in our script is there. So Terraform's done, apply complete. It has 5 added resources, nothing changed, nothing destroyed. As I said, the database URI is sensitive. so it's not shown here, but I can actually see my SKS endpoint. Now let's have a look if I also got a node pool. Yes, so I can also see the node pool here. So this deployment actually is done. So let's create a kubeconfig. For the cluster DB as a service webinar prod. I want to name my kubeconfig admin, and I want to have it the system master's role. I give it a time and second to be valid. That's 1 day times 7, because a week should be sufficient. And I actually pipe the outcome into the default folder for the Kubernetes config on a Linux system. That's the home folder.kube name config. If I now use the kubectl get nodes, and there we go, I can see my 2 nodes. You see the name over here. They're both ready. So my Kubernetes deployment is completely ready to go. And I can actually start deploying my Kubernetes deployment, my pods, to start developing the service. But what about the database? First, what I need to do is getting the URI. So let me show that deployment, and -u is for the URI. And this is actually my access. So you see it's Postgres is the username, it's the password for this given username. Then we have the endpoint for Aiven Cloud. And here you can see SSL mode is required. It's neither optional nor none, but it needs to actually encrypt the connection. So I use my Postgres client I have on the system, copy paste the entire URL, and there we go. I'm connected to the Aiven Postgres service in the backend. I can list the databases. We have the Aiven database in there as well as the default databases. And now I can also start using this database to actually get my web service running for the customer. And now let's assume we've done through the development process. The web application is there, it's running, it's fine. So initially we said we're running on the least amount of resources to keep the development costs down, but now the customer wants to go productive. And we can't go productive with only 2 nodes and a small startup database. So let's jump back in our Terraform script and let's edit this file. So we keep the same zone, that's fine. We keep the same security rules because that's also fine. But then when we come to the node pools, we don't want to have small size anymore. We want to have large nodes, and we don't want to have only 2, but 5 of them. When it comes to the Postgres, it should be reliable. So let's take a business plan, because you have a local replication, and actually increase the resources as well. And as we're going live, I want to have a termination protection on my database, because that's where the data resides. And I never want this to get deleted accidentally. Looking good. So changed deployment resources from development to production scope. We document our changes so everyone can see that I actually changed the resources from development to production, as well as in the commit, you can clearly see what I changed. So how to apply this? First is I do a git pull to actually get the latest release, the latest revision, sorry. Perfect, file changed. And now I just run Terraform apply again. Again, I gave it a key. I give it a value. And now it's going to upgrade the database from startup 4 to business 8. It's going to change termination protection from false to true. And it's going to increase instance or change the instance size from standard small to standard large, from 2 nodes to 5 nodes. Perfect. That's exactly what we wanted to do. So let's get this going. Terraform again is doing its magic in the backend. And now we actually can have a look. And there we see our database is now in the plan of business 8. And now the Aiven integration is doing its magic in the backend to actually create the replication, keep them up to date, as well as you get the increased backup rotations and increased failover, as Dave explained in his session. If we have a look at the node pool, we now see it's 5 nodes. State is running. So the node pool is all there. Let's have a look if those nodes already deployed. They're not completely deployed, but they're in the state of getting ready. So if I query my Kubernetes master now about the nodes it's aware of, you clearly see you have additional nodes, and now it's not only 2, but 5 nodes. So that easily, we completely increased a deployment from a development sizing into a production sizing using Terraform. Now coming to the last deployment, he wants to have the same service in Vienna. So what we're doing, we just add a different project name. Change the zone. And that's it. We document our change. We commit the changes. And now instead of using the same directory, I will create a new directory. The reason why is if I would apply this plan here, it would remove all services in Frankfurt and redeploy them in Vienna, because each checkout actually has the state. And these are the Terraform state files. So instead of doing the apply in the same directory, what I'm actually doing is creating a directory, doing the checkout again into this directory. Running a Terraform init as before. Running a Terraform apply to actually apply the same code base again. And now Terraforming is deploying exactly the same environment, same sizing, same configuration, same content in a different location. And actually, this can be perfectly integrated into your build process, so you don't even have to execute the Terraform by hand, but you can also configure this to be integrated as deeply as the deployment happens on a final commit into production. While this is creating, just let us have a look. If I now list my Kubernetes clusters, I can see I have 2 Kubernetes clusters, one in Frankfurt, one in Vienna. And it's not yet reached that stage, but it will actually create all the databases. That's for the demo. So it's time for the Q&A, and I would like to hand over to Benjamin again.
Thank you very much. So, just a short thing. So, thank you, Antoine, Dave, and Philip about the insights around data protection in database as a service environments. In the meantime, we received a big amount of questions that we would like to answer in the Q&A session. So we ask all speakers to turn on their cameras again. So as we still have around 25 minutes, it might be that we cannot answer or challenge all the questions, but however, we have everything collected. And if we are not answering a question, we will follow up personally with you and make the connection there. So my first question to the round is, I guess, headed to Antoine. How is the current backup restore procedure? Probably I missed something, but the attendant checked out the documentation, database as a service quick start, and occupied that there are currently restoring backup is not described in the docs.
Yes, that's correct. So for next week, hopefully, for the TA, you will get from the documentation all the descriptions. I think Philip already showed in the Terraform manifest that, I mean, you can fine tune the options regarding backups. So that's all accessible as tunables for the various services, and starting a new database instance from a backup is already something which is possible with the CLI, just not completely documented. Just reach out to support. We'll get you going. Remember that, like I think David explained, you don't restore. I mean, restoring a backup will not be on top of the of an existing database instance. It's always a fork. Okay, so you switch. We don't with this platform. We don't overwrite data on an existing service.
Thank you. The next questions came up at the beginning of Philip's presentation. So this is the question about to get access to the Terraform example you already showed. So my intention were to give that in the follow-up email so everybody could access that. Is that okay?
So I actually will screen the repository for any sensible data, and if it's fine, we can just switch that GitHub repository to be public readable and provide the link.
Perfect. So for everybody, this will be in the follow-up email, at least some descriptions about it.
Yeah, no problem sharing the Terraform manifest, I guess.
Yep. So the next question is, which database service included in the Exo portfolio? I can see PostgreSQL, but any other providers?
I don't understand the provider part. I mean, the flavors we are releasing right now are Postgres, Kafka, and Kafka Mirror Maker go together, and Redis. Okay. MySQL is going to be next in the lineup.
Thank you. The next question is it possible to integrate GitOps in this topic to avoid applying manual changes from Terraform apply?
Philip, I guess you touched on that, but maybe.
So actually, there will always be a resource in your environment that is capable to either change infrastructure parts manually or directly change manifests locally and apply, same as for your development processes. So actually, that's more a process challenge to actually keep your DevOps engineers, keep your system administrators, your developers to stick to the process in committing in your revision tool and deploying through the build process you've defined. So I can't see who's someone who has actually root access to a system as well as readable access to the Terraform. Writable access to the Terraform can change it locally.
There's plenty of GitOps solutions. Just pick the one you prefer. I mean, the presentation from Philip was really just focusing on the capabilities of the providers, of the Exoscale provider, and showing a lot of manual things. But there are plenty of solutions out there. I mean, from very simple ones that get plug into your workflow, like I don't know, Atlantis, KubeStack, etc. I mean, plenty.
Wide range. The next question is, can we assume that the mentioned security high availability backups features for Postgres, are the same for MySQL?
Dave, do you want to take that one?
Yes, certainly on the Aiven platform today, the
It is,
backups work the same way for Postgres and MySQL. So I assume that when we expose that feature through Exoscale, it'll work in the same way. Yes, so point-in-time recovery as well as full snapshots will be taken for MySQL in exactly the same way as we described.
Thank you. Next question is, will there be an automatism to align the SKS node pool sizing and the database plans? In a demo, these needed to be adapted, synchronized manually.
I mean, not from us. So we don't have any packages predefined for Terraform or ZCLI to get a certain amount of compute and database resources, because that's completely dependent on the application you run, how you need to scale those. But again, that's something, if you have a tool for building and deploying a Terraform, you can actually in this tool certainly replace code blocks, and then they could define such blocks for your developers to use. Like you could define a development scale sizing, a production scale sizing, and a premium, or like that should be possible. But there's nothing pre-made available from us.
Thank you. Now comes a really short question. ETA for MySQL? Question mark.
Contact us, but I mean, just a few weeks, really. It's there.
A short answer. Next question is, what about the support of MariaDB?
So let's say MySQL is planned as on the main Aiven platform. I see also a question regarding Oracle and SQL Server. So that's not our motto. This platform is made for automating, orchestrating open source data infrastructure engines. So this is what we'll focus on.
Thank you. So the next question is, when will MySQL be supported? But I guess you already covered that one.
Same, yeah.
The next is, can we scale down a plan?
You can indeed, yes. There are some protections in place to make sure you don't scale down if the destination plan you're going through is too small to fit the data you have. So there are some automatic checks in place, but in general, that is possible to do.
Thank you. The next question is, can I export a database backup?
And so no, the backups they're private to the platform. I mean, one reason for that is as Dave mentioned, that they are fully encrypted and extra, so there's no direct access to those backups. However, I mean, those data services, for example, take the example of Postgres or MySQL, you just can use any other external tool, and a traditional dump will work. I mean, you are the database admin for those engines. So nothing prevents you from taking that copy by yourself, plugging another tool. That will all work.
Thank you. Next question's coming in. Is there an easy option to update the DB version, e.g. PG12 to PG13?
Yes, you can do that. I'm not sure whether support for that is through the CLI or Terraform provider yet. Maybe Antoine or Philip can answer that part. But in general, yes, you can upgrade the database, and that is a automatic and seamless process. A new server of the target version is built, and then all the data gets streamed across seamlessly. Any conversions that need to happen for compatibility happen automatically too. So while the upgrade procedure is happening, the actual database service as a whole will remain accessible throughout. So you don't even need to take any downtime while that upgrade is in process.
Thank you very much. So we do have another one. Is it possible to dump a DB dump to a S3 bucket?
Again, I think dependent on the database engine. Really easy, for example, with Postgres native, you can point that directly to any S3 compatible platform. So yes, but I mean, we don't provide additional tooling than which data infrastructure engine provides.
Thank you. So we're coming to the last question so far. So this is the chance for all the attendees to raise questions. Can we connect via a private network?
Private network, no, they're not supported with Exoscale DBaaS as a service. But like Dave showed, I mean, there's protection all the way, privacy all the way. So it's you effectively have a tunnel from your applications and clients to the database. You have boundary protection as well, so meaning you can restrict very precisely who connects, who are the nodes that can connect to the data infrastructure. So this is all private to you.
Thank you. Now there are coming some questions in. So that was not the last one. The question is, because the person missed the first 10 minutes, is it our database as a service managed on Exoscale or Aiven platform?
All right, so the service we are running is everything runs on the Exoscale infrastructure, okay? You use it using Exoscale tools, like we've seen the CLI, the API, soon as well the web interface, all the orchestration and level 3 support we get from Aiven as a technology partner.
Thank you. The next one is pointing out to Postgres. Does a fork in other region follow the original one? If yes, in which interval does the data get written to the fork? He's asking for a disaster recovery.
Not for a fork, no. It's sort of like an initial copy paste, and then that is a standalone database of its own. I'm not sure yet if the Exoscale integration we've got today allows you to create a read replica in a different zone. And that's something that is available through Aiven directly today, but I'm not sure we can do that through Exoscale.
Not yet, but definitely something to add on the roadmap.
Yeah.
So roadmap is increasing. The last question so far, if there's no short notices, is there a way to monitor PostgreSQL cluster health to know when an issue is happening, the progress of self-healing process?
Philip, do you want to answer? Because maybe.
Yes, so actually there is. Through the CLI, you can actually currently look at the state of the cluster. And you can see stuff like if the replication is in place, if it's currently refreshing or reestablishing a replication, as well as I believe you can also see the lag in seconds currently occurring. And you will see the same information for your master, if it's healthy or not. And we will also integrate this into the web UI once it's done. So you will be able to get your information either manually by looking at it, or you can use the Exoscale to automate and actually push those things into a third-party source to like your monitoring system.
Thank you very much. So no short notices or questions raised in the meantime, or maybe there's another coming in. So that's just like a market today. Is it possible to prevent updates in a certain time frame so that in critical times in business, no interruption can happen?
The maintenance window, I guess, Dave, no?
Not quite the same thing. So the maintenance window is the time
Yeah.
period automatic updates might be applied for bug fixes and things. We've got termination protection to prevent anyone accidentally turning off the service, but there's no real change freeze option that's controlled through tooling. So really that would have to be done by shutting down access to the API perhaps, or if you centrally control your Terraform repository, then not accepting any commits for a time or not applying them rather. But yeah, the tooling today doesn't really enforce any change freeze like that.
Thank you. So attendees get into mood right now. Another question, is there a way to gather metrics on resources to know when to scale up?
So I can take the part for the Kubernetes. In a default Kubernetes deployment, we deploy the Kubernetes dashboard. And the Kubernetes dashboard gives you insight about your nodes resources, as well as what is running on those nodes, and that can actually be used to implement an auto-scaling process, or at least, again, integrate into your monitoring system to give you a heads up when your nodes are quite utilized. So Dave, I would hand over to you for the database.
Yeah, I think this might end up being another roadmap point. Antoine, looking to you for confirmation here, because I know how I do this on the Aiven platform today. We offer other open source services like Grafana and
Exactly, yeah.
Influx on M3, which we can collect metrics in and then have its service integrations to hook these things together. So maybe that's the end goal, is we'll have the same experience through Exoscale, where you've got a Postgres service running alongside a time series database and a visualization tool like Grafana. We can hook all those things up, and then the metrics from one will flow through and you can monitor that as you like. Don't believe any of that's there today, so I couldn't comment on timescales.
Correct. So it's not there yet, but the plan is really to add those additional services as we go along the way with the metrics and the dashboards. And so that when you provision a new database engine, it will automatically send both, I mean, it's logs and metrics to those instances. So you have your full platform working.
Thank you. And another question is coming up. I do not get how forking into another data center helps me in solving disaster recovery in case the whole data center blows up. I'm asking for Postgres. How can I have the data backed up to another zone automatically?
Automatically. Okay. You need to trigger that call to fork it on a regular basis. Currently, correct, Dave?
Yeah. So without the read replica, the cross-zone read replica capability, it's a bit limited. You're right. So yeah, the backups will be continually happening in the same zone. the fork be a one-time thing. If you're not updating that anymore, then your most recent changes don't get applied. So that's a really good point. And yeah, so we'll have to get back to you about the roadmap feature about the read replica, which is a proper replicated stack. So
I'll need to follow up more precisely on this one. It's a very, very good point. Thank you.
Thank you. So there is an addition. Let's maybe get back to the first question of the certain time frame for critical times to for the business interruption. There's a question about time frame no for critical patches. Maybe that's an addition to the question.
We might want to take this one offline. I don't get it. The question about time frame.
Okay, so my suggestion would be to take the person on call and take him offline. Okay.
So when you create, I mean, the concept of maintenance window is when you create a database instance, you can choose when is your preferred moment for those patches. And it's up to the, I mean, if you don't define it, it's random. If you define it, it's on this specific slot. Is it possible to skip it altogether to deactivate the maintenance? I don't think so. And you should not do that.
You don't need to rely on the maintenance window. You can trigger the updates at a sooner time. But in terms of skipping that and not applying maintenance updates for a long time, I'm not sure. Yeah, obviously wouldn't be recommended for various reasons like security, but yeah, I'm not sure what's possible there.
I mean, I think, I mean, if you're asking this question, I think, I mean, the answer is that you should not use a startup version. You should already be into a business or more plan so that you have this kind of rolling upgrade also mechanism and always have the service up. Okay.
I think we can take that one really offline and I will connect you two guys. Maybe that's a better way of communication at that point.
I think so, yeah.
Good. So at the end, we can close that one 5 minutes earlier so we can have a coffee break before the next meeting marathon is starting. So many thanks to our speakers and the openness in answering the questions. Likewise, I thank our large audience for the privilege of your time. And a final note, you will receive tomorrow during the day the address documents and the recording by mail. On that note, I wish you a pleasant rest of the working day and see you soon.